So in the last video, we inspected the output of the tf_echo command. Also, I mentioned at the end of the last video that we might even see some warnings and errors when we execute the tf_echo command. In order to understand why this could be the case, let's understand the idea of query timing in TF. We first learned that transform information is continuously updated over time by the robot state publisher package. Second, we learned that transform information is published on the /tf topic, and once we start the robot's state publisher ROS node, the /tf topic is continuously published. However, we cannot always guarantee that the point in time we query for a transformation between source and target frames exactly coincides with the publication of the TF topic as well. So, if we query for a transform that will be published in the future, we will receive an error saying the particular source or target frame is not yet available. And if the particular transform was indeed published already at the time of query, we will receive a warning we might be working with old transform data. A simple analogy would be to ask yourself now what you had for dinner 5 days ago, or what you intend to have 5 days later. In the former case, you might recollect something, but you may not be sure if it's correct. And in the latter case, you simply wouldn't know. Nevertheless, we will soon see that the warnings or errors do go away once the desired frames are refreshed or become available. So let's first switch to a terminal and start the hrwros_environment.launch after we have sourced our workspace setup files. We wait for the launch to complete without any errors and also ensure that all our robots are visible. Remember, if you don't see one of the robots, just terminate the launch with Ctrl+C and restart the hrwros_environment.launch again until all robots are shown at the desired locations. Once we have this ready, we can open up a new terminal and source our workspace setup files again and use the rosrun tf_echo command to print the transform between, let's say, world and baselink of the Turtlebot. Notice now that the tf_echo command first prints out an error message to us saying it is not aware of the requested transform yet. However, after a short while, the desired transform does become available and the output is displayed. So this is exactly what we learned just a couple of minutes ago. At the time of query, TF is unable to retrieve the requested information because the query timing was either too soon, before the next refresh, or too late since the last refresh. Good. Now, let's move on to another extremely useful command line tool, view_frames. We can run this command as follows. Notice that I'm using the same terminal to type this command, and also I terminated the tf_echo command with a Ctrl+C. So before we type the command and hit enter, remember, we still have our hrwros_environment.launch running in another terminal. And that launch file includes the robot state publisher, which publishes TF information. Without a ROS application running with an active TF publisher, this command viewFrames will not return any useful result. Alright, now the command rosrun tf view_frames and we hit enter. Here we will observe two things. First, the command will listen to the TF topic for 5 seconds and then generate a PDF file called frames.pdf in the same folder where we run this command. And this PDF file contains the TF tree, which we will soon examine further. But remember again, the frames.pdf file will be in the same folder. So, let's go to that folder using the File application in the launcher, and then we will directly open the PDF file in the PDF viewer. Now, by default, Ubuntu comes with Evince, but if you have something else installed like Adobe Acrobat or Foxit Reader, that's fine too. Any PDF reader will do. So, let's open the file then. And since the tree is quite big in our ROS application, and it usually is in real-world applications as well, we will have to zoom into the file and move around to be able to read the contents of the TF tree. So, let me zoom in a bit like this. Now, I go to the top of the TF tree by scrolling up. The reason why this is called a TF tree is quite obvious, right? It has the names of all the TF frames in our factory simulation application, and the topmost frame, which is actually called the root frame, is the one that is the parent of all other frames which are considered its children and subchildren along the TF family tree. So, in our case, the root frame is called map, and all the other frames are always connected to the root frame via an unbroken path. This view frames command is an extremely useful debugging method to find out if the TF for your ROS application has been set up properly. If this tree is broken somewhere and you are using TF in your application, then you know things will not work. We will soon see how a broken tree looks like, just to get an idea of what typically happens when we start out with ROS and TF. Anyway, let's walk down one branch of this tree to understand it. We will first go from map to world to robot2_pedestal_link, and then all the way to the robot2 end effector we set up in MoveIt, which was the vacuum_gripper2_suction cup. Let's also read the contents displayed in the ellipses and along the edges of the tree to complete our understanding of the TF tree. First, notice that the text in the ellipses refer to names of the robot links. So, this is important to remember, and it is a convention. Remember also that the TF frames are located at joint origins, and they take the name of the link corresponding to the joint, except for the root frame. So, for example, the robot2_pedestal_link is the name of the robot pedestal link, and it is connected to the world via a joint we defined in week 2. And the second thing we will look into in the TF tree are the information on the edges of the tree. First, we see which ROS node is publishing the TF reference frame. Then, the rate at which this specific transform between the frames is being published. And last, and the most important, the time at which this specific transform is published. This timing information is what we discussed a little earlier about the query time and refresh time of TF reference frames. Alright, note that TF frames can also be created without joints. This is where the next command line tool static_transform_publisher is useful. We will learn more about it and also see what a disconnected tree looks like in the next video.